Hi, let's begin our introduction on Hadoop. Last classes we have discussed about some basic concept related to big data and Hadoop. Today we'll try to explore more in the terms of big data. So let's begin with a very basic thing, like what is the difference between Hadoop and versus RDBMS. When I say RDBMS, it means SQL. Okay, so like the first point is Hadoop believes in horizontal scaling, whereas SQL believes in vertical scaling. What does it mean? I have discussed this in last class also. It's similar, right? Okay, let me just go through it. So what do you mean by horizontal scaling and vertical scaling? So let's say I discuss vertical scaling. Okay, so suppose this is your system. Suppose this is your system. Upgradation in a same system is called vertical scaling. Upgradation in a same system is called vertical scaling. What does it mean? Suppose you bought a computer which is having initial RAM of 2 GB and a hard disk of 500 GB, suppose. Now after few years, what you did, you added or you upgraded your system with another 4 GB RAM. Also you changed your hard disk to 1 TB. So you are doing upgradation in a same system. Okay, so why we usually upgrade our system? So that our system to make our system more efficient in dealing with all the latest softwares or the product, whatever you want to run as per your requirement, right? So after some time, okay, after suppose you did it in means in 2 years you did one upgradation. Now next year if you'll think, okay, let me upgrade to another 8 GB RAM and then hard disk of some capacity, let's say 2 TB. But at some point of time, the time will come when your system won't allow upgradation, right? So we'll talk about that, like what if, I mean, if it's not allowing upgradation, then what if, like you are dealing with petabytes of data, then how will deal with the data with a single system? So vertical scaling means you are upgrading your system you are upgrading a same system. You are upgrading a same system. Okay, so this is your vertical scaling. I hope I'm clear. So now let's say I'll come to horizontal one. What do you mean by horizontal? In horizontal, what you are going to do, that you are connecting multiple commodity hardware. Commodity hardware means a daily uses system, which can be 10 years old also, doesn't matter. You are connecting lot of systems together horizontally. Okay, horizontally. Okay, and let's say that's not a problem if each system comprise of 4 GB of RAM. 4 GB of RAM. Okay, 4 GB of RAM and some 2 TB of hard disk. Let's say 1 TB only, 1 TB, and it is similar it is similar, the same configuration in each and every system, and you are making a master system. That is also nothing but a commodity hardware. Okay. So if I say what is the strength of this entire, okay, now one more thing came into my mind, like this entire combination of system is called cluster, where you have one master and the node that you can say it as a slave. So these are called nodes. So node is nothing but a system only, a computer. That's it. That is called a node. But node is managed by some another system. So the system which is managing that node is called master node, and rest are called slave nodes. But we can say master system and the node. So this is your node, and this is your master. Node is like is a used term for for a system, and so we can say it as, sorry, we can say it as slave. So this is your slave node. So I'll write that. Okay. Now if I'll ask you, then okay, what's the capacity of a system? What you will say? Total capacity. So total capacity is 20 GB and hard disk 5 TB. Tomorrow if you want to add another 5 system, you can add, and there is no limitation. There is no limitation. So it is giving you a clear picture. When you are dealing with chunk amount of data, humongous amount of data, you should always prefer a vertical scaling instead of horizontal scaling instead of vertical scaling. So horizontal scaling doesn't have any limitation. You can add n number of nodes, but in vertical scaling there will be a point like your system won't allow upgradation. So this is your horizontal scaling. So that's what I was discussing, that Hadoop believes in horizontal scaling. I can say it has to, I mean, why? Because Hadoop will deal with lot of data, whereas SQL believes in vertical scaling. Okay. Now our next point. In SQL, we write queries, right? We write queries to process data, but we have a concept called, but in Hadoop we have a concept called MapReduce program, which handles everything. The next term. What is this MapReduce? I'll come to that later when we will explore Hadoop more, when we'll dive in details like, okay, what are the things available in Hadoop, because everything in Hadoop is called MapReduce. As of now, you just learn by heart, like everything, whatever we'll do, whatever operation Hadoop will do, everything will be MapReduce only. Okay, so I can I can just I mean, it's not the right time to explain these things in a detail because it won't be good. So let's discuss other differences that we have. So SQL is designed, as we all know, to store. SQL is designed to store the data in tabular form. Okay, whereas Hadoop store data in key value pair. Likewise, suppose if we have a table called employees table. So how we usually store or how we visualize the data in RDBMS? Like suppose we have employee ID, right? Then employee name, then designation. Okay, so some name will give, that's fine. This is the employee ID, some name. Designation is like let it be developer, then another ID we can give, let's say TL. So this is the tabular format that we have in SQL. That is the way SQL used to store the data. But when it comes to but when it comes to Hadoop, it usually stores the data in a key value pair. Likewise, suppose you have employees table, so it would be like this. This would be your key called as EMP name and the value 1001. Okay, then this is employee ID. Employee ID 1001, employee name key colon value, which is your name, EMP name, designation there should be developer. So this is the way how usually this is called a key value pair storage technique, right? So Hadoop follow this, like it always is to store the data in a key value format. So you can see, guys, that this is a NoSQL. This is a SQL, so this is a NoSQL way of storing a data. Next difference is, so I believe like from the last videos I'm always explaining like, okay, Hadoop is good here, Hadoop is good here, and SQL has these many limitations. So does it mean like we don't need SQL or RDBMS concept anymore? No, it's not the truth, right? When we are dealing with big data, then SQL is not ideal solution, right? Because we have calculated that it might take a year to evaluate and to give you an output. Okay, but when there is a small data or when there is a real time processing, okay, when suppose you are doing any transaction, right? Like you go and you are withdrawing money from bank, from an ATM, and so instantly that is an instant operation, right? Like your transaction detail and money deduction from your account and giving all sorts of update should be very quick. Okay, it cannot be like an hour delay or a 2-hour delay or a 2 days delay. You cannot afford that. We cannot afford that, right? So still there we need RDBMS concept. So SQL is for real time processing of data, whereas Hadoop is designed for batch processing of data. Batch, the literal meaning of batch processing is like you are executing list of jobs without manual intervention. So means like you executed a job and that will be finished by themselves, like it's an automatic process, but it will take time. You are not expecting the output instantly. Okay, so like you said, okay, I have started my job and I want to finish this within a 1 day, 2 day, 10 days, 15 days is also fine, but this is like, okay, I am not expecting the output quickly. So Hadoop is designed for such purpose. Okay, next difference in SQL, you can update the record. But in Hadoop, you cannot update the record. So now the thing is, like, you say, okay, how come, like, I mean, then this is a limitation of Hadoop? No, we cannot say it as a limitation, but it's not, you know, ideal to, when you have a lot of data, to do a update kind of operation to delete the things, right? So suppose if you okay, now you say, no, I did something, I did some mistake, now I really want to update something. So there is only one way. Suppose you have employees.txt, which is having a size of 1 TB, and you have uploaded it, and you want to do some change on it. So there is only one way. First you download it, whatever, and you add your new, I mean, whatever the modified file into the Hadoop. That is the only way you can update the record. But there is no provision provided by Hadoop to update the record, because it's really not an ideal practice to slow down the system completely for updating a single thing, right? So Hadoop never allow you to update the record, and in SQL we are not dealing with the big data, so it's allowed. Hadoop is free, that we have discussed in last class also, with Apache, which is taking ownership of entire thing of developing the Hadoop, which is free with Hadoop license, and also commodity hardware is sufficient. But in SQL, we cannot go with the commodity hardware. We need, in SQL, servers are I can say SQL servers. SQL servers are high-end servers. Okay, high-end servers with expensive hardwares. Okay, when I say expensive, means high-end configuration with a vertical system. So so high, and one more thing I want to add here, that expensive hardwares means like the hard disk, which is RAD disk, I can say. Where in Hadoop it is fine to have a simple non-reliable hardware. Okay. So overall, what we found with all the differences, like I know it's difficult to remember all together, but when we actually go through the classes and when we figure out, okay, these are the things that why we cannot use SQL at this point of time, it is always ideal to use Hadoop. And also we'll get to know, like, okay, when we have a lot of data, then how to deal with that. Then it would be an automatic process that you will get to learn all these things by heart. So just the thing is, like, you need to focus a lot on whatever statement I'm putting here. So I think we should move forward with the differences. We are good, like Hadoop believes in horizontal scaling and vertical scaling. So that's why we approach horizontal. Why? Because we are dealing with a lot of data. So I emphasizing on this point. Why? Because we will work on the clusters, we will work on the nodes. So single node system, multi-node system, lot of things are there. So that's why I'm emphasizing this point more and more, that the vertical scaling means when you are connecting a lot of system, and you are and the capacity of the combination of those system, you are expecting that as the entire capacity. Okay, and the vertical scaling is like upgrading a single system. Okay, now I'll tell you that this combination of entire system known as, or it is called, cluster. Okay, this is a cluster where you have nodes, connected nodes. Nodes is nothing but a system, and a master node who is operating all the nodes. Now yesterday, one more thing I was pointing out, like you need to install a virtual machine where you will install Hadoop. So what kind of cluster it is? What kind of system it is? As you are working on a single system, so it will be single node cluster. Okay, so we can install multi-node also. We have to do some partition, we have to define sizes, but it's ideal for learning perspective. Single node is fine. So so these are the terminology that you need to know, like, okay, before processing multiple things. So let's move forward and understand a few more details. Okay, so I'll explain this. Yeah. Oh. So this is your entire cluster, which I can say a Hadoop cluster. Now you want to store data. That's what we are talking about, right? I want to store a data. So it's a big data. So how we can store the data in this cluster? Okay. So we'll understand how data actually divides and how it is getting actually stored in multiple nodes or system or everything. So this is your cluster. Now suppose, let's say you have a file called as employees.txt, which is of which is of 1 TB, which equivalents to 1024 GB. Okay, now you want to store this file into your cluster, and this is your cluster, right? So you want to store this file into this cluster. Okay, so tell me how many nodes you have. 1, okay, 2, 3, 4 and 5. Okay. So there are a lot of things that I cannot tell right now because it's not the right time, but I can give you the high level overview that, okay, how a file actually stored in a node. So so you have 5 nodes. So how this file, 1024 GB of file, which is 1 TB of file, and which is equivalent to a node size also, I can say. I think it's too much. Let's minimize it to 10. Okay, for understanding, let's okay, let's make it GB. Okay, let's make it 1 GB, and this has 1 MB. Concentrate, guys. So we want to store 1 GB of data, which is equivalent to 1024 MB into our cluster. So as we know, as we learned in our primary classes also, like how actually our memory looks like. So memory always looks like a tabular format, which is nothing but you created one table, then you have lines, right, like this. So these are your lines, right? Sorry guys, it's not much perfect. So this is how memory looks like, right, in a tabular format. Okay, now each box is called as block, right? This is one block. When I say one block of data, so what is a block? A small unit of data, I mean small unit of data, yeah, which stores small unit of storage, I can say, which will store the data. A block, a box, store a data. Okay, so in Hadoop 2, so there are versions, guys, like we have Hadoop 1, now we have Hadoop 2. So in Hadoop 2, each block size is 128 MB, which was earlier, it was in Hadoop 1 it was 64 MB. I hope it's clear, like this is our block. So this block size in Hadoop 2 is now is 128 MB, and in Hadoop 1 it was 64 MB. So it's better to talk about Hadoop 2 only, right? So let's understand our requirement. Like, okay, this is my employee.txt, suppose. This is my employees.txt, and I have few lines, like let's say I have to design it again. Employee ID, employee name, and designation. Okay, I think let's keep 3 columns as of now. So it's in tabular format. Okay, so I have a data I have a data that is there in 10. This is employee ID, this is some name, designation is like anything, TL, then 1002, then some developer 3, then let it be manager. Okay, so we have 104 developer only. I think we have a lot of data actually, so because we have to reach to 1024. So okay, so let me copy few. So now we'll change it 4, 5, 6, 7, 8. Okay, let's keep the designation and name same as. So we have suppose 8 record. So don't think it is in a tabular format. It can be in any format. It can be like, you know, comma separated value, like in this braces with separated with comma. So the value can be like this also, or can be with a space also. So I am showing in a tabular format so that it will be clear to you guys. Okay, so Hadoop can store structural data, unstructured data, semi-structured data as well. So we have this record. Okay, now let's say each record is of size Okay, so we have total size of 1024 MB. Okay, so now I want to store this in a cluster. So let's say each line is of one, suppose to let's keep it 100 MB guys, 100 MB. Okay, each line is of 100 MB. I have to add more, I guess. Okay, I'll write that. So let me copy 2 more. Okay, done. So we have 10 records, each of 100 MB, and so it will make us a total of 1000 MB. Let's say size is almost same, round to 1000 MB. Now each record is of how many MBs? 100 MB. So what will happen? Your one line and the block size is of 128 MB. So tell me what will happen. How many blocks will get accommodated with this file? How many number of blocks? So let's count. 128 MB. So this first line will go in the first block for sure. Still there is some space. So with that space and the remaining block size space means 28, then 100 minus 28 will be stored in the next block. So can we count in the way that number of blocks. So block size of 128 MB, then number of blocks will be how many? 10, right? 10 only, right? Yeah, because 128 MB, 128 into I think if we do 8 only, I think, right? Which will give 1024. Yeah, so I think 8, sorry. So 8 block is sufficient for handling this 1000 MB of file. So number of blocks required, 8 blocks. Okay, so when I will send employees dot txt to our cluster, when I will send employees dot txt to our cluster, how many blocks will get filled? How many blocks will get filled? 1, 2, 3, 4, 5, 6, 7 and 8. Why? Because we already discussed that each box is of 128 MB and there is still, after storing a line, there will be still some space inside it. So another 28 MB will be filled by this line and then it will store in the another block. So if we'll count the total size with the total capacity, with the individual capacity of the block, we can count like, okay, number of blocks which will be accommodated in this Hadoop I mean, in this node, I'll come to that. In this node will be 8 blocks. So this employees.txt will be over 8 blocks. Okay. So this is your block of memory. So when these all blocks combine, this form as a total capacity of a node. So this is completely, if I say, okay, this is my all set of memory. So I can say that, okay, this is my, suppose this is your hard disk. This is your hard disk of 1 TB. This is your hard disk of 1 TB, which is and the hard disk is inside a node only, no? So let's say is inside node 1. Done. So so you can get a picture that each node 1, 2, 3, 4, 5, each node are having this kind of structure because we store a data in this form only, in blocks only, and in Hadoop 2 each block is of 128 MB. So a total size file of 1000 MB will be on 8 block. So you can understand that in this cluster, so this employees.txt can either reside on first cluster or on second cluster or on third or on fourth or on fifth, but how many number of blocks it will accommodate? It will accommodate total number of blocks will be will be 8. And how we are calculating it? How we are calculating it? Total file size divided by individual block size. This is the way how we are calculating, right? Yeah. So yeah, okay. So let me recap the things overall, like what we have discussed. We have discussed about the difference between Hadoop and RDBMS SQL, and we came to the conclusion that, okay, when we are dealing with the big data, then we will go for Hadoop, and Hadoop always believes in horizontal scaling. Horizontal scaling means adding n number of system, or we can say as a node, to a single node, which will act as a master node to have a control over each slave nodes. Then we also got to know that when we are dealing with the real-time data, then SQL is the ideal solution for us. Also then we understood the terminology, like, okay, what do you mean by cluster, what do you mean by node, and then how actually a file, I mean, when you are sending a file, it's just it's a 1 GB, which is nothing. In the field of big data, we deals in the petabyte, zettabyte. So I believe you get a picture of, with a small data only, but you get a picture that how actually a data reside on a node. So suppose if you have a file of 1 GB, and so it can either reside to any one of the node, but the way it will be stored in this form only, because why? Because our hard disk usually have this block concept, which is in tabular format, and each field is called as a block, which is having some size. Okay, so suppose if you have file of 1 GB, which is of 1024 MB, and then if you want to store on your Hadoop cluster, then it will accommodate total 8 blocks of size. So this is the way, guys, how files actually, or your data, I can say file is just a txt. So it can be any file, Avro format, or CSV, or txt, whatever, whether it's in a structured format or it's in an unstructured format, semi-structured format, it will be stored in this pattern only. And this is the way how data stored in Hadoop cluster. So this is it for today. So we'll discuss about other concepts of Hadoop, and also the installation of a single node cluster in upcoming videos. Thank you.